Hello, everyone. Welcome to Ceramic Speaks. It's been a while, due to this current pandemic situation. Hope everybody safe and sound, and also your families and your beloved one, everybody safe from this pandemic. So as you all know, that Ceramic software, we normally organize the meetups. Yeah, and right now today we have to do the webinar due to the current situation. So my name is Joseph. I'm the talent acquisition team. Yeah, so today we have like an Android webinar, flows, biometric, and safe navigation for Android. All right, so some of you already know who we are, Ceramic Software. We are like a software design agency based in Thailand. Yeah, we are originally from Norway and we relocated to Thailand since 2014. So we've been in Thailand for 7 years. Yeah, we're helping a lot of clients in Thailand, and also we have international clients, and also we have like European clients. We're helping for a lot of business sector as well. So some of you already used to attend our meetups before. You used to visit our office at the park, which is connected with MRT Queen City Gate. Yeah, it's just sad that we cannot set up like a meetup for now. So we would like to keep doing what we used to do. So we moved to the webinar. So today you will be learning a lot of Android things. Yeah, how the flows, biometric, and also safe navigation, which is very interesting topic we have. All right, so you can also like and follow our Facebook page and also the LinkedIn, because we always update all of our activities, and also we have like case study sharings. Yeah, very interesting topics we always share on the social medias for our followers. So please make sure to like and follow so you will not miss any of our update from Ceramic Software. Yeah, of course, Ceramic Software, we're growing very fast. We have like 22 different nationalities. We work very hard, and we also pretty hard. Those photos, just the moment before lockdown. So we have enjoyed a lot of catamaran trick. We have a lot of birdie inside, and also we have outgoing activities a lot. Of course, we stay doing online things. We always share and make fun and play the games online. We stay keep doing. So this is the moment that we used to have it before. And we also did a lot of support. Sports it's also another thing. We have a lot of groups. Someone gymnastic or CrossFit, or we also play the game, PlayStations, Xbox in the office as well. So we really mix back to the office, meet with our awesome people to have those kind of activity. Hopefully this pandemic may be over soon. Yeah, and of course we also eat hard. Yeah, as well. We have a free lunch every Thursday, as you see that we have different international cuisine in the office, so people can try a different taste, and also they can mingle around the cross-functional teams. And we also have other activities like wine tasting that you see in the photos. And well, we have a lot of activities in the office, so we hope to do those kind of activities again in the office. Yeah, right. So we stay hiring. Yeah, even though this pandemic cannot stop us from hiring. We are growing very fast, and we're almost 100 people right now. So, but we're still looking for more talented developer who is in Thailand will be better for now due to the location. But of course, we open for everybody who are interested to work in the remotely from the different city, from Chiang Mai or Phuket. That you can also apply. We're looking for more .NET developer, front end, and also Scrum Master, backend Android developers, UX UI designers, iOS developer, and software QA engineers. You can check out our opening position on our website, ceramic-software.com/careers, and you can also send your profile, your CV to jobs at Ceramic Software. So our team will review it and then get back to you as possible. And if you're not looking for at this moment, you can also share this very good opportunity to your friends and colleagues who are looking for the job to join with the international team, to have an awesome we are helping for the very well-known clients in Thailand and also internationally. So yeah, please feel free to share, refer the people, or if you're interested in Ceramic Software, please kindly send your CV. Yeah. You can also check out our event page. You can scan this QR. We always update like all the webinars is coming up. So we are preparing, more interesting topic, and also we will share more things on our social media channels, and we might also send some email to some of you guys who have like an email list. And all right, so this is the Android webinar. So today, the main topic is like flows, biometrics, and safe navigation for the Android. So we have 3 speakers today. So the first speaker, he will talk about like utilizing Kotlin Flows in the Android application. The second speaker will talk about establishing secure biometric authentications in the Android. And the third speaker, last but not least, he will talk about the safe navigation with the Android navigation component. If you have any questions, feel free to raise your hand or send your questions in the chat box. So our speaker will take a look at the questions, and they might take the questions and they will answer right away. Or if they cannot answer, like due to a lot of questions, we will definitely get back you guys, like get to each individual. So feel free to drop your questions, or if you have any suggestions or anything, if you have any questions regarding this webinar, or if you would like to listen other topic in the future, you can also put any comment in the chat box. Thank you guys. So I would like to invite our first speaker, Vijay. So he's gonna talk about utilizing Kotlin Flows in the Android applications. Are you ready, Vijay?
Yeah. Hi.
All right, cool.
Hi, everyone. All right. Hi all. My name is Vijay Patel, and I'm working as senior Android developer here at 7Peaks. Today, I'll be presenting how to utilize Kotlin Flows in an Android application. I will also include channels in the discussion. So basically, we'll cover Kotlin Flows and channels. So these 2 features are basically included in the Kotlin coroutine libraries. So let's look into those and how we can use these tools in our Android application development. We'll see moving forward. All right, so before starting anything, I would like to discuss what kind of challenges we face while developing Android applications. So challenges, one of the main challenge we face is related to asynchrony. So in the asynchronous, there are following challenges which we face, whether it may be a network request or whether it may be a database readings. Asynchrony is something which is persistent, which stays there. So some of the challenges under asynchrony are like race conditions, one of the very common issue, back pressure. Basically, while developing streaming applications, we face this back pressure issues. There are some leaked resources. We also have threads, and we know how threads are expensive. They can also starve each other. Deadlocks may occur between them, and several other asynchrony issues. So to solve this asynchrony issue in Kotlin, we developed a library called coroutines. So coroutines is basically a backbone behind Kotlin flows and channels. So before moving forward with the flows and channels, I would like to discuss a little about coroutines, a little fundamentals about the coroutines. So I'm sure you might have used Kotlin coroutines before, but I would like to go into why Kotlin coroutines are so powerful. So some of the features of Kotlin coroutines are they are lightweight. So you can run multiple coroutines in a single thread due to the support of suspension. So they basically that don't block the thread where the coroutines are running. One of the incredible feature that is the suspension feature. Another, we have fewer memory leaks. Uh, uh, because we use structured concurrency, so there are fewer memory leaks. We also have built-in cancellation support, and many Jetpack libraries, they have a support for coroutines. They provide full support for coroutines. So basically what coroutines are, coroutines can suspend. Now, uh, if I think about this thing, for the first time, I understand it like as coroutines can suspend means they can pause. Basically, it's like hitting a pause button. So let's say when a coroutine is running inside a thread, so they can stop and resume later so that the thread can operate on some other asynchronous processes, probably some other coroutine. So, and it does so basically by choosing when to suspend and when to resume. So let's say we have two coroutines here, uh, one on the left and one on the right. Both coroutines are running concurrently. So threads can decide which coroutine should suspend and which can resume. So it's something like the threads can switch between the coroutines. It's something like they are interweave among each other. So this will not block the other process uh, while ongoing the process. Now, here, if we want to continue, uh, if we want to use some state in the coroutines, let's say we want to continue to operate some sort of changing states in the coroutines. And one of the ways we can do this is by communicating between the coroutines by using the thing called channels. But before moving forward with the channels, we need to make sure that the shared mutable, we need to avoid the shared mutable state. We just want to communicate between two coroutines and share, we don't want to share the shared mutable state. We just want to uh, share some state, that's it. So channels. So what are channels? So channels are basically, they are like a pipe. We can send some information and we can receive some information from them. So they are like synchronization primitive. Like we can send some information into them and they can spit some information out. They are like a non-blocking queue. So they have a separate suspending function to send the information to the channel, and they have a separate suspending function to receive the information from the channel. So let's see how, with a simple demo here, how channel works. So on the left, you can see we have a channel of strings. Uh, this is basically represented by a pipe on the right side. And we have a coroutine number 1 and coroutine number 2, which are basically which basically iterates through the channel using the for loop to receive some values from through it. And now we have coroutine number 3, which is basically a list of strings, specifically A, B, C, and D. So let's say if we want to send some information, so if we want to send some information over a channel, we call channel.send. And here the coroutine number 3, which is our producing coroutine, will try to send some information. So let's say it tries to send value A over the channel. Now, coroutine 1 and coroutine 2, based on their availability, they can try to receive that value. So here in this case, coroutine 1 can receive that value through the channel using the for loop iterating over the channel. Then we have Then let's say another value, the producing coroutine number 3 that tries to send another value over the channel. Coroutine, now in this case, if coroutine 2 is available, it tries to receive that value. It does the same, it tries over the channel and try to receive that value. But while coroutine 1 and coroutine 2 are processing the value, the coroutine number 3 reacts to this scenario by suspending itself. So it can suspend for some time while the processing of the values is done. So once the processing of value is done, it can start sending the values again. So based on the availability, if coroutine 1 is available, it can try to receive that value. And same goes with the coroutine number 2. If it's available, it can receive that value. And once the iterating over the list is done, we can close the channel. We can also do this by using produce builder. So the advantage of using a produce builder is that we don't have to reference channels inside the builder, and we also don't have to close it explicitly. So now the coroutine number 3, the producing coroutine, does the same thing. It tries to send the elements of a list one by one to the other coroutine. Great. So channels are, what are the takeaways here? The takeaways are basically, they are like a non-blocking queue, and they are a synchronization primitives, like they allow us to send data safely to other parts of our application. But channels are hot. So basically what happens is channels tries to consume some resources before anything receives the information from that particular channel. So this is the reason they are inefficient, and they are not safe and not easy to implement as compared to other tools. So the engineers, they wanted some abstraction over the cold streams, which can basically lazily be consumed, and it is much more safer and easier to consume. So they come up with the idea of flow. So what is flow? Here, basically, there are 3 entities involved. There's one producer, one intermediary, and then we have a consumer. So in Kotlin, in coroutines, a flow is basically which can send multiple sequential values. And as compared to, as opposed to the suspend function, they are much more better. Suspend functions can send only one value at a time, but flows can send multiple values. They can emit basically. So here there are 3 entities involved. There's a producer, there's an intermediary, and consumer. So producer produces the values and then sends it over the stream. And then we have intermediary. So intermediary, basically it tries to modify the value over the stream, or it can modify the stream itself. And then the consumer consumes the value and use it further. So how we can see in a demo. So let's say if we have a flow of integer values, which is depicted by a tube on the right side. Right now, the tube is gray. So for now, we are just declaring the flow of integers, and we are using flow builder to display, which basically has a list of integers 1, 2, and 3. And for each integer, we will try to emit. So for now, the tube is a gray color. Why? Because we don't have any collector flow to collect this emitted values. So right now we have just declared, and it's not declared inside any coroutine, it's just being declared. So let's say if we want to collect these emitted values, so then we have a, then we declare a numbers.collect inside a coroutine. So this numbers.collect is basically a flow collector, which will collect the numbers and then try to update the UI. So how this gonna work? So basically we have three values and one tube. The first tube is basically a flow builder, another is a flow collector, and then we have a UI. So how it works basically. So the flow builder, for the first flow builder, when we try to emit any value, that particular value will be sent over the tube, and the collect builder, the flow collector will try to collect that value and accordingly update the UI. At the same time, another value, the flow builder produces that value, emits that value, flow collector collects it, update the UI. Same goes with the third, and the flow collector collects it and updates the UI. So basically, it's nothing but a single coroutine only. So as you can see here, we have only one coroutine, which basically collects. So we can say that there's only one coroutine involved. So flow builder just emits the value and the flow collector just collects it and update the UI. So here is only one coroutine, and here we end the flow and coroutines. Great. So another form of flow is a buffered flow. So what is a buffered flow? So let's go with the same example, but uh, instead of directly collecting, we have a buffer before we collect the numbers. So what exactly this is? So let's say we have a producing coroutine and the collecting coroutine. So here, in some cases, in some scenarios, we would like to hold some values before we start emitting inside the flow. So in those cases, we use buffered flow. So as you can see here, when we use the buffered flow, it basically introduces a channel between the builder and the collector. So this particular channel is nothing but a buffered channel. This buffered channel can provide us the functionality which we just saw with the flow, that there's just one coroutine involved, and this buffer channel can hold some value for the some time. Once the flow collector is available, then once the flow collector is available, they can start emitting one by one. So if we talk about what else can be a flow, so let's say we can declare a list of integers as a flow. We also have a flow of, or more simpler, we can say flow of 1, 2, and 3, nothing but an integer again. We can have a functional type of flow. We can also have a suspending functional as flow. We can have live data objects as flow as well. So anything can be a flow, basically. And flows are like just one coroutine, have a buffered channel, and so much more. So let's look into how we can consume this popular flow tool inside our Android application. So we'll go with a simple demo. But before going with the demo, the recommended architecture, the modern architecture for Android development is this. So basically here we have activity and fragment as views, then view models, then we have repository, some models and remote data source. We can also present this as, let's say we have a view and we have a view model. The views basically observe the live data from inside the view model. And on the right side, we have repository and data source. So the data source is, we can say it as the one which makes the network request. So inside the data source, it can be a remote data source as well as a local local data source, which is nothing but a local database. So basically, it produces a flow, and the repository gets that flow from the data source. Now, to bridge the gap, we have use case layer in between repository and view model. That is nothing but a business. We can implement the business logic in the use case layer, which ultimately does the same, gets the flow from the repository and pass it to the view model and use to observe in the view. All right. So now in the example here, we will try to create a list of article headlines. And to do so, we will try to use flow to create the flow of a list of articles, and then we'll try to consume those lists and display over the view. So as you know, here we have a class named news remote data source. Now, news remote data source basically takes basically has a property named latest news, which is nothing but a flow list of article headlines. And it takes news API as a dependency, which makes the network calls and exposes a suspending function. Now, here we are using the flow builder. This flow builder, as we are inside a coroutine, so coroutines can suspend. So let's say if we want to, inside the flow builder, here, if we want to make multiple network requests, we are looping, we are using a while loop, which will continuously try to make network requests and get the latest news. And why we are doing so? Because we'll try to fetch the latest news from the server and try to display it over the UI so that the requirement is fulfilled. And to fetch the information, to fetch the latest news, we call fetch latest news suspending function to get all the latest news. And with its results, we pass that result to emit and pass it over the flow so that it can flow all the way up to the view to display the latest news. Here, we are using another suspend function called delay, which has a delay of 5 seconds. So let's say while we are trying to fetch some network requests, while we are trying to fetch some network response, at that time we can delay for some few seconds and then another iteration will go on. All right. Now, as I discussed, we have 3 parameters in the flow. We have producer, we have intermediaries, and we have consumers. So the remote data source is basically acting as the producer of the flow. And we can modify those streams by using some intermediary operators. So intermediary operators are like, they can perform some operations over the flow of stream. So basically we can modify some stream and then present it over the UI to present it to the user. So here in the news repository, as you can see, we are using 2 values. One is news remote data source, which is basically the producer of the flow of streams. And we have a user data, which is nothing but we can get the information of the logged in user from it. And then we have a property called favorite latest news, which is nothing but a flow of list of article headlines. Then we try to fetch the latest news from news remote data source. And then we apply some intermediary operators like map. So map can transform the latest news, and we can apply some filtering to get the actual favorite topics of the user interest. And then we are calling on each, which is nothing but a side effect where whatever the news are being filtered, we are saving those news in the cache. Now, here we can, with the help of intermediary operators, we we can just modify the stream of data. But to trigger the producer to produce the values, we have to call collect. So here, as you can see in the latest news view model, we are calling news repository dot favorite latest news dot collect. So collect is a suspending function, is a terminal operator. When we call this collect terminal operator, this operator triggers the producer to produce the latest news after a certain time interval and can refresh the news and pass the flow here. So collect basically takes the lambda parameter, and we can update the view with the latest favorite news here. So collect, unless we call the collect, the producer will not start emitting as we saw earlier. We can also collect the flows on the view. So to do so, we can call a safer way to call to collect the from a flow is by calling repeat on lifecycle. So repeat on lifecycle basically is a suspending function which takes lifecycle.state as a parameter and which can uh, automatically create and launch the uh, block of code which we have passed inside. So it will automatically uh, trigger the producer to produce the values and can collect and can update the list. And let's say when we move, if at all, when we move out of the lifecycle state, let's say if we go out of the lifecycle state dot pause, at that time it will automatically uh, stop collecting the values. So what hap there's another way to collect the values on the views. So another way is basically to call flow with lifecycle. So flow with lifecycle basically it uses the repeat on lifecycle under the hood, and these are used basically to collect just one value. So whenever we want to collect multiple values, we can use repeat on lifecycle. But if we want to just collect single value, we call flow with lifecycle. And it also manages and automatically terminates or start collecting based on uh, when the UI moves into the lifecycle state or when it moves out of the lifecycle state. Cool. So now let's say in while we are trying to fetch some data from the remote source, we can use some third-party libraries. So while using third-party libraries, we might face some sort of exceptions. So to handle those exceptions, basically we can call catch. So catch can be called in the view model before we collect any flow of stream, or it can be called inside the repository to emit the last cache news so that we can handle any unexpected exceptions. Great. Now, since flows are greatly adapted all over the world, and we have a full support inside all the Jetpack libraries, we have a full support for flow. So we can also use flow along with room. So here, as you can see, if at all we have uh, any update in the local database, the values in the local database. So for example, if we have any updated elements in the article headline table, then we can send this, uh, we can emit these values right away to the UI to get updated UI and whatever we have inside the updated article headline table. So I'm sure if you guys have any questions, like you can raise. And this is all I've got to present for today. If you guys have any questions, you can put up in the chat. I will try to answer you guys. And if we have no questions so far, then I would like to pass on. I would like to invite Sifat to for the next presentation. That's all. Thank you. I hope this was insightful.
Yeah, so hello everyone. Uh, Good evening. This is Sifat. I have been working here at 7 Peaks as a senior Android developer. And today I'd like to discuss about AndroidX Biometric, how we can integrate AndroidX Biometric in our project. So let's get started with it. First of all, as a user, I think all of us have some sort of experience with biometric APIs, especially in the wallet applications or banking applications. So what AndroidX Biometric is a library which provides us a set of APIs which we can use to integrate the AndroidX to integrate the biometric authentication in our Android application. So first of all, fingerprint manager was introduced back in Android 6 API level 23. There were two major issues with this fingerprint manager. One was that it didn't have any UI, and the other was it only provide developer access to the fingerprint sensor. As you know that other kind of biometric are getting popular day by day in modern day, like facial recognition. So developer actually started to give feedback, and also as there wasn't any UI, so developer has to build their own custom UI. That was another problem because different devices has different kind of sensor. For example, some devices has sensors in the display itself, and some devices has sensor in the back. So as a developer, we have to build a custom UI for different kind of sensors. So taking these feedbacks into account, Google framework team and security team started working on this. And in Android 9, they published fingerprint UI policy and also the biometric prompt. So the biometric prompt actually gave us access to not only the fingerprint sensor, but also the other biometric sensor that the developer can use to authenticate an user. And also it provides us an simple UI, which as a developer we can customize. We can just set some parameter to it, and we don't have to build the UI from scratch. And one another advantage of this was the device manufacturer now can customize this UI to fit the need of their particular device. And later in Android 10, biometric manager was introduced. So the biometric manager gave us the API to check whether the device supports biometric authentication or not. Also, it provides us a fallback. If we want to use the non-biometric credentials like PIN, password, or pattern as a fallback to the biometric authentication, we can do that. So backward support, the AndroidX Biometric API provides support all the way back to API 23. And if you want to use the non-biometric credentials like PIN, password, or patterns, it can provide you support till API 21. So now the steps to integrate this library in our project. So you can see that there are very simple 5 steps there. First of all, we need to add the library dependency in our application module. Then we have to check whether the device supports biometric authentication or not. Then we have to build a prompt info object. Then we have to create a biometric prompt. Then we have to ask the user to authenticate himself. We'll see these steps in detail in our later slides. So first of all, the Gradle dependency. So right now the stable version is 1.1.0. So you can add this dependency in your app level Gradle file and sync the project. You will get access to all the AndroidX biometric API. And then you have to check whether the device supports the biometric authentication or not. To do that, you can simply call the can authenticate method of the biometric manager. And you can see we have to pass an integer value in the parameter. So what the integer value represents is that the type of authentication you are looking for. So here you can pass one of these 3 authenticators. The biometric weak for non-crypto authentication, the biometric strong for crypto-based authentication, and the device credentials for non-biometric credentials like PIN, password, or pattern. Now you can combine this flag as well. So if you want to add the device credential as a fallback to your biometric authentication, you can combine biometric weak with the device credential and create a new flag. So, but you have to keep in mind that not all the combinations are supported over all the APIs. For example, you cannot combine the biometric strong and device credential in API level 28 and 29. It is not supported there. And also prior to API 30, you cannot use only device credential. So yeah, these things you should be considering. And later, building the prompt info. So what is a prompt info? A prompt info is our way to set the metadata and configuration for the biometric prompt. So using the prompt info, there is a builder method. So you can set the title, the subtitle, and the description of the biometric prompt. And there are other methods, but among them, I would like to talk especially about these 2 methods. One is set allowed authentication integer. So here you can also see we have to pass an integer. This is the same as the type of authentication you are looking for. So if you want to use the device credential, non-device credential as fallback, you can add here. And then there is another method, set confirmation required. Here we can enable or disable confirmation button. So it if we enable it, it will add additional layer of confirmation. So user has to explicitly press the confirm button to even after authenticate himself with the biometric authentication. So in the image below, you can see the difference between the enable state and the disable state. The default behavior is the enable state. And also, this behavior can be overwritten by the device manufacturer. So it's in some devices, you might not see this confirm button. And then the biometric prompt. For the biometric prompt, we need 4 basic components here. The first one is the fragment activity or the fragment from which the biometric prompt will get the fragment manager. and also the context, and then the prompt info that we just created. And then we have to add a authentication callback. So it has three methods. Authentication succeed, as the name is suggesting that it will be called when the authentication is successful. The authentication error will be called if there is any kind of unrecoverable error. For example, if user presses the back button, or user haven't enrolled any biometric credential yet, or the device doesn't support the biometric authentication. So in those cases, you will get the callback here, the authentication error. And the next one is the authentication failed. So the authentication failed will be called if the user input an invalid credential. For example, if the user input a wrong PIN, or user input a wrong finger to the sensor. So this method will be called. And now, unlike the first two methods, the authentication fail is not a terminal method. What does it means? It means that if you get a call to the fail method, user can still verify himself. So you can get subsequent call. You can get further calls, callback in the succeed or the error. So the fail is not a terminal callback for this one. And lastly, we have to pass an executor. It's optional. By default, the callback method, this executor actually represents in which thread this callback will be executed. So by default, this callback will be executed in the same thread the biometric authentication will be called from. But if you want to declare a separate thread, or if you want this callback to run on UI thread, you can specify explicitly here contact compact.get main executor. And the next one is to show the authentication dialog to the user. To show the prompt, simply call biometric prompt.authenticate with the prompt info that we created. And we can also cancel the biometric prompt programmatically by calling the biometric prompt.get cancel authentication. So now let's jump into the code and see this authentication in action. So first of all, you can see that as a step one, I have added the biometric dependency here. And in the main activity, so in the main activity here is a step two, where we are actually checking, we are creating instance of the biometric manager, and we are checking whether device is supporting biometric authentication or not. So here you can see that I have combined the biometric week with the biometric credentials. So I have added the non-biometric credential as a fallback method. So you can see that there are lots of statuses here. So biometric success, as the name suggests, it will be called if everything is okay and the device is supporting the biometric authentication, there is no problem. So this, you will get this value, gets the status, and then the biometric error, no hardware. This means that the device is not supporting the biometric authentication. The hardware unavailable is that the sensor is currently unavailable, so you have to try again later. The device is compatible with the biometric authentication, but the sensor is right now busy. And then the biometric error non-enrolled. This will be called when the user haven't registered any biometric information. The user haven't enrolled any PIN or any fingerprint or facial recognition, and so on. There are other subsequent statuses here. So once we get this success, we have to call the other method to show the prompt here. In step three, you can see that I am creating the prompt info here. I'm setting the title, the subtitle, and the description. And here, set allowed authentication. I am setting the device credential as a fallback, and also I'm setting this to true. This is true by default, but still I'm setting it. And I'm building the prompt info. Then I'm creating the executor and creating the biometric prompt here with the activity, which is a fragment activity, and the executor and the callback. And finally, I am showing the biometric prompt here by calling biometric prompt.authenticate with the prompt info. So here in the callback, you'll see that there are three methods here. So one is successful, the other is error, and the other one is failed, couldn't recognize the user. So now let's run the project. So here you can see that no biometric or device credential is enrolled because right now I haven't registered any biometric information in the emulator. So let's quickly set this up. For this, we have to go to the settings. Go to the fingerprint security, and I'm choosing PIN, fingerprint plus PIN. I'm trusting you guys with my PIN. And then get set. Let's input the scanner here, sorry, fingerprint. So here in the fingerprint, you can see that there are lots of fingerprint here, 10 of them. I will select number 3 and touch the sensor. Touch the sensor, again. Yeah, so now the finger 3 has been registered. Now let's go to the application again. And now you can see the biometric prompt has been popped up, and I can use the pin here. First, I will enter a wrong one. Yeah, wrong pin. And you can see the authentication is successful. And if I click outside, you can see unrecoverable error because the prompt was cancelled. Then let's try a different finger here. Finger 1, you can see that couldn't recognize the user. Finger 5, couldn't recognize the user. So now let's try finger 3, and you can see that the authentication is successful. So now I will do only the weak one. And for this, I have to specify the negative text. Otherwise, the application would crash. So yeah, right now you can see that there is no fallback. There is only a cancel button. There is no fallback. So I have to enter the finger. Otherwise, it won't be validated. So yes, that's all for the integration of the biometric authentication in the application, in your Android application. So is there any question on this? Otherwise, I will hand it over to Dimitrii. We'll take the next session. Thank
So
you, everyone.
Vijay, a few questions.
Sorry?
There's a few questions for Vijay. So 1 second, and I'll just.
Yeah. All right. So, so one of the questions I got is from Mr. Zubair Rahman, right? So the question is, what is the difference between repeat on lifecycle and launch when started? So for this question, I would like to uh, tell you, like while I was presenting, I showed one slide wherein I showed a safer way to collect the flows in the UI. So that safer way was using a repeat on lifecycle uh, function. So basically what happens is, let's say if we are, I'll consider one example. So while we are collecting some kind of Kotlin flows on the UI layer, there is a chance of wasting some sort of resources. So the resources can be like CPU cycles, or maybe memory, or there might be some memory leaks involved. So to handle these cases, we use repeat on lifecycle uh, instead of launch when started. Now, let's consider one scenario. In if we want a location updates, in an example, if we want some location updates, so we can use one of the form of flow that is nothing but a callback flow to emit the uh, location updates sequentially. So while on UI layer, if we use launch when started to get the to collect the emitted flow of location updates. So what happens is, if at all we try to go back to the, let's say if we put the application in the background. So what happens is, launch when started will suspend the coroutine. It will not try to process the whatever the location updates are emitted. It will not try to process those values. But what happens is, the callback flow which we are using in the background to emit those flows of the location updates, it is hot. It keeps on sending those, it keeps on emitting those updates to the UI. So what happens is, even though we are not, or even though if our application is not on the foreground, it still consumes a lot of CPU cycles and the memory is wasted. So to avoid this case, we use a safer way to load the UI. So to collect the flows safely on the UI, we use repeat on lifecycle. Now, there is one caveat. When we use launch when started, at that time, we can cancel the job which started the coroutine. So what we can do is we can cancel that particular job while we are trying to collect the flows while using launch when started. At that time, we can, on destroy, we can just cancel the job, and this will save some memory, and this will also not waste the CPU cycles. But this is boilerplate. And in the Android, we don't want to write the boilerplate code. So to avoid this boilerplate, we use repeat on lifecycle. So repeat on lifecycle helps us to reduce the boilerplate, and it is lifecycle aware. So what happens, let's say if we move into a started state, a started lifecycle state, it will start processing the uh, flow. And when we move out of the, let's say if we go in a pause state of, or else if we go in the background state, it will automatically suspend the coroutine and it will not uh, fetch and process the uh, flow. So this is how, this is the main difference between repeat on lifecycle and launch when started. I'm sure I answer your question, Zubey. And another question that I got is from Titre Nimagnong. The question is, I have a question about flow. What is the difference between flow and live data? All right. So the difference between flow and live data is basically flow have some extra intermediary operators which live data don't have. For example, let's say if we try to collect some emitted flow, so we can apply some transformation. So for example, uh, I showed one example where we use buffered flow. So we can apply dot buffer function that is not available with live data. And there are many more operators which are available with flow, but which are not available with live data. And another difference is uh, even though a general flow, a regular flow is not lifecycle aware, while the live data is lifecycle aware. But in conjunction, we can use state flow with callback flows. We can use state flows with repeat on lifecycle, which is now again, as I mentioned in the first answer, that repeat on lifecycle is lifecycle aware. So if we use state flow in conjunction with repeat on lifecycle, which is lifecycle aware, then we can also have one step ahead of the live data. So all in all, we can use like flows are, if we can say, flows are much more reactive. But if I compare with the RX Java, flows don't have so many operators, but they still have enough, which are like more than live data. So that's why they are like +1 than the live data. So yeah, this is the answer for that question. Any other questions you may have? All right, so if not, then we would like to invite Dimitrii for the next presentation.
So
I have few questions. Yeah.
For Sifat.
Yeah. So the first one is, can we save custom data using a biometric API so that we can use it later? I think a biometric API is for only just for authentication that you authenticating that user. I don't think it provides us any API so that we can save information there. As far as I know. The next question is it possible to use the library for iris scanner? Yes, it is. As a developer, we don't have to worry about what kind of scanner the device is supporting. That is being taken care of by the library itself. So it's just providing us the necessary API so that we can use this API to authenticate the user. We don't have to worry about the authentication the device supports. But yes, the iris scanner also is also supported by this library. And can we integrate this with my own UI of biometric? As far as I know that you can. Android is providing us the UI, but they also provide us the the UI policy. So if you meet the policy, you can build a custom UI, but I don't think you'd like it because it will be very difficult to manage that UI across all different devices and all different uh, authentication sensors. How can we encrypt and decrypt our data using biometric API? So can I share my screen here? Yeah,
Yes.
I think you guys can see my screen.
Yes, it works
So
perfectly.
here, yeah. So here in the success callback, you can see that we are getting an authentication result. So first of all, you have to change it to a strong, biometric strong, and then in the callback, you will get a crypto object. So you can use this crypto object to decrypt or encrypt the data. And also there is the authentication type. The authentication type you specified here, the alert authenticator. So in the result, you will get the object to encrypt and decrypt the data. I think that answers your question. Any other question?
I think that was it for now. But if you have any questions, just ask them in the question sections, and then I think we'll give it over to Dimitrii.
Yeah.
Hello, everyone. My name is Dimitrii. I'm Android technical lead at 7px, and today I would like to talk about Android navigation and the simple implementation of Android navigation in applications as Android navigation component. So what is Android navigation, and what is the ways how we can implement it in our apps? So common flow looks like this, and when you have only a few screens in your application, Android navigation is pretty simple. So you just have Android launcher where you tap your application icon, start your application, and have the first screen. And according to action on this screen, you have to navigate to another screens and so on. What if you have much more screens and much more actions in your application, and as well as a lot of flags, or maybe deep links or some external actions? Navigation can become quite messy, and you have to implement some additional classes, some additional managers maybe, or controllers. And as Android doesn't provide any specific patterns for this or any strict requirements for Android navigation in Android apps, you have to take care about this basically yourself. But usually we have few ways of implementation how we can switch between screens in our apps, and let's talk about these ways, these patterns. Multiple activities. This pretty simple pattern or pretty simple way which we can use to switch between screens in Android application. In this pattern, every screen is a single activity which basically can be forwarded user to any next screen, and of course bring user back. This pattern is very common and exists, I think, from the first versions of Android release. And of course, it's most simple way of implementation Android navigation, but it contains some disadvantages. One of these is disadvantages if we use a lot of activities. Application can have much overhead because activity is quite heavy, and as well as we have to implement some additional navigation manager which will take care of switching between screens. And as soon as we have more than two screens, this logic of navigation between screens can become very complex. Another pattern which we can use is a single activity pattern. When we have only one single activity in our application and implement every screen as a single fragment. As well, we can use in our main activity or our activities that we have in our application, like frame layout or any other container, which can be used as a content holder for fragments. We can use one or maybe more activities. It depends on your solution or depends on your business logic. This from one side can simplify the navigation because it have fragments, and fragments is more lightweight than activities. But also we have the same similar problem, same we had in our previous pattern, is implementation of additional component, additional manager or controller for take care of navigation between these screens. How we can solve this? We can use some external solutions like Android Navigation Component. Android Navigation Component is a new library, a set of libraries that introduced not so long time ago and become very popular and used as a modern way implementation of navigation in Android apps. What is Android Navigation Component? Android Navigation Component already contains Android controller, navigation controller, and contains a navigation graph. Or if you want, it can contain small graphs according to your requirements, of course. So basically, navigation graph is the simple fragments or dialogues or any fragment related views, and the actions or directions between these fragments which we can use to switch between screens. So how this works, I will show you in the live coding. So let's switch to Android Studio. First of all, we have to add dependencies for Android Navigation Component. And these dependencies can be found on Jetpack page. And the next action that we have to do is prepare our screens. In this application, we will have just a few screens. It will be basic list of items, and will be the details screen, which contains more detailed information about every item. We will not focus on design of these screens or specific implementation, but continue with Android Navigation Component. So next step, after we added our dependencies, we have to go to activity, which we will use as a host for our fragments, and add the container. As a container, we can use fragment container view from AndroidX library, and the next step is navigation graph. To set up navigation graph, we have to create basically the map or list of our fragments, description of fragments. So let's do this. The first action here is create the package called navigation and located in resources of your project. Let's create a navigation resource file in this package. I'll call it navigation map. So this navigation map can be automatically used in our container. And this navigation file, this navigation map, should contain the list of our fragments and actions which will be called between them or externally to switch between our screens. So the main item here is the navigation, the root item, and the next one, the child's, is the fragments. The fragment should contain the ID, let's call it list screen. As well, it should contain the class file, which we will use for this fragment. It will be this fragment. And we can use the layout parameter from tools namespace just to see it in preview. So as you see in preview screen, now we have the one screen, one fragment, which we just added. Let's add the second one, which we will use as a detail screen. Okay, so now we have two screens, two fragments in our navigation graph, which we can use in our navigation. But as you can see in preview, we don't have any relation between these screens, and we have to add this relation or action between these fragments. To add the action, we have to add additional parameters to our list fragment or our list screen, which called action. Action contains ID. Let's show details, and as well destination. Destination is the ID of fragment from this navigation map, from this navigation graph, which we want to show next after user call this action. As well, we should add some additional actions to our route navigation graph. Route navigation parameter is start destination. Start destination is a screen which will show first when we just add this navigation graph to our container view at main activity. As you can see on preview, now we have arrow to show exactly the action which will happen when user call this action. So let's call this action from our list view. In our list view, we have already implemented adapter, list adapter, which pass as item from this list, which we can send to detail screen. So everything that we need to do is find the navigation controller, which we just added. And navigate according to action. One more thing, as we have item which we need to pass from one screen to another, we have to use the common feature of fragments is pass a data as a bundle. So let's do this. Okay. And now we can open our details fragment and read our arguments. Same we usually do when we use fragments. We support fragment manager or just fragment manager. Get arguments, our parsable object. And show it on the screen. Let's see how it looks like. Okay, so we have a list of countries, and as soon as we click select any country from the list, we get a detailed screen with additional information. Okay, this works pretty well, and actually don't need any additional managers or additional features. But sometimes in our navigation map, when we assign some IDs or assign some parameters, we can make the basic typo. So let's say we have the text field here. Which will have the similar ID detail screen. Let's see, show details screen. Navigation controller and navigate function doesn't check the ID, the type of ID. So we basically can put any ID from entire project without any problem. But as soon as we try to use this action, application will crash. Yeah, Android Studio will not show you any warnings, and as well compiler will not show you any warnings or any issues in your log. But in runtime, yeah, application will crash. So how can we avoid these crashes and use some type safety? Android navigation component contains some additional features. These features calls Safe Arcs. Safe Arcs is basically a Kotlin plugin or Gradle plugin, which we can add to our other class path in project Gradle file build, and as a plugin, our application Gradle file. As soon as we add it, this plugin will generate additional classes for every item, every fragment in our navigation graph, which we can use to navigate between these fragments, between these screens. What is the advantages of these additional objects, additional classes? They provide the basic type safety. So how we can use them? We have to set up additional parameters or arguments in our navigation graph. So use argument parameters, which we will call country here. Set up the argument type. Argument type is basically the class of our object. It can be any native type, which no need to implement as parcelable or serializable. But if you use some external, some additional type, some custom classes, you have to implement parcelable interface. So let's use our country class. Here we have a few additional parameters, which is default value, which we can set right here in navigation graph. Sometimes it's very useful, so you can avoid of strictly set it in your actions from the fragment, and set parameter as an argument as a nullable or not. In our case, it will not be nullable, so we force the user all the time, force the developer all the time, set the country parameter, country argument, and let's back to our list fragment. And as before, we used the navigation through action ID. We will use safe arguments generated classes. So how how these classes looks like. It's basically the same as name of your current fragment with additional suffix is directions. So in our case, it will look like list fragment directions, and action is show details. Show details, and we pass our object here. All this navigation action we have to pass to navigation controller. Navigation controller, navigate, and pass it here. As soon as we make this, we can come back to details fragment and use some additional features from navigation arcs, from save arcs according to this fragment. As well as save arcs generate class for direction for source fragment. The same generate class for the destination. And this destination class looks like this. Let's call it arcs. So it will have the same name as current fragment, but with arc suffix in the end, and initialize it by navigation arguments. So instead of require arguments type function and try to call nullable get parseable with unknown result, we have to check our arcs parameter and get the country arguments from there. As you can see, all our generated classes and provided actions is null safety and type safety. So basically, we cannot pass anything else here, like ID or anything else. So we can pass only exactly what is expected by our navigation graph. So let's see how it works. The result will be exactly the same. That's how you can implement safe navigation in your apps without any issues like forgotten parameters or typos in navigation keys or something like this. So that's pretty much it about navigation components. If you have any questions, you can ask them in chat.
We have 2 questions.
Okay.
You see them on your screen now? The questions?
No.
No. Oh, okay, then let me just read them here.
Can you forward them?
The first question is, how do you choose between using? Oh, sorry. What is the bundle size increase for using this package?
Bundle size increasing according to this package, it's not much. Yeah, it have some generated classes, but I think it's not much important because it's only the code and it's pretty optimized code. So there is not much overhead which will be in your package, in your bundle.
Yes, and if there's any questions, please answer them or put them in the question section. We have one more question here, which is, how do you choose between using activity and fragment in each page of your project?
If there is no have specific requirements, it's absolutely up to developer how to what developer is prefer to use. If you have simple navigation, you can use just activities. If you have some expecting some old devices in your for your projects, expecting some old devices, users with old devices, you should think about using fragments, as it doesn't have so much overhead, and it will simplify the navigation graph, and it will be much more performant than using the activities. Of course, on new device, on the flagships, you cannot see much differences between using activities or fragments, and they will be pretty similar, and you will not see logs, let's say, or some additional side effects. But if you are a developer and if you have some low-end device, you can easily check how it's look like when you use some activity with a lot of views and some additional stuff doing on initializing. You can see how it's look like when you're using activities and when you use fragments.
I think that was the last question. Maybe we can just give the attendees 1 more minute if there's any other questions.
Okay, let's wait. Are we still waiting? Some our attendees can join our Facebook, follow us there.
And we also sent out survey to you guys in the chat. So if you guys can use a few minutes filling out that one so we can improve our webinars. And next week, we will also be sharing the recordings and the presentations with all of you in our Cement Peak Speaks group on Facebook. I think there is no more questions for now. So I think we can say goodbye to everyone and thank you for your time.
Okay, thanks everyone who joined us today and listen our interesting topics. See you in Facebook, LinkedIn, and our social pages. See you again. Bye bye.
Bye bye.